In this video, I'm going to show you the elimination method for solving a system of linear equations. Now there's a couple things at the top of my paper here that I have for us to fill out, and those blanks are going to be these words right here. Name two ways that we've already learned to solve a linear system. One of those ways is graphing, and the second way we've learned so far is substitution. And then the third way we're going to learn today is called elimination. Now with elimination, the process is really just finding a variable that you can eliminate from your two equations. And so what we want to look for is what is called opposite coefficients of the letter that you choose to eliminate. So for example, negative 3y and positive 3y will eliminate your y and get you no y's, hence the name elimination. Negative x plus x gets you no x's, or 100 a's minus 100 a's gets you no a's. And so the point is to eliminate one of the variables so that you can solve for the other variable that's left. And then once you get a value, you can plug it back in and solve for the second missing value. So again, I'll just kind of re-emphasize those steps. Number one, arrange your equation with like terms in columns. Number two, multiply one or perhaps both equations by a number to obtain a coefficient that will be opposite in sign. For example, that would be 5x and a negative 5x, or a positive y and a negative y. Number three, add your two equations from step two. Combine the like terms, and you'll notice that one of your variables should be completely eliminated. So then you solve for the remaining variable. And then you check your solution after you have found your second missing variable. So I want to show you a couple equations here just to kind of get this started. So the key here is to get your equations arranged so that like terms are in columns. And sometimes your equations don't start that way. You need to rearrange your terms to get them to be that way. Most of the time what we say is to get your functions in standard form for elimination. And so I want to show you that your first function is in standard form, where you have an x term in the front, followed by a y term, and then equal to your constant on the right side of your equal sign. But notice how the second equation is not in standard form, and so we're going to rearrange this. And how we're going to do that is we're going to add 5x to go back out in the front on the left side of our equal sign. So if I do that, I'm going to have a 5x followed by a 2y and equal to the 12 that's over there on the right side. And now notice my first equation that we had is arranged in standard form. We have 3x, we have our 2y, and we have our 8. Now I'm not going to do the process of solving just yet, and so I just want you to see what we're going to start with is just arranging our terms so that our like terms are in columns. Now here's the next one. Both of these functions need to be rearranged, and so for this function, what I'm going to do is add y to the left. So if I add a y here and I add a y here, I'll have 2x in the front, followed by the y that I added to the left side, equal to the number 150. And then for my second function, I want to add my x to the left. And then in that function, I'll have my x out in the front that I moved in to the left side of the equal sign, plus the 2y that was already there, and that will equal 150. And then for the last one, just kind of rearranging your terms so that they go in order, in standard form order. For this one here, I'm going to subtract my 5y to the left side. So if I subtract it, I'll start with my x term, followed by my subtracted y term, equal to the number negative 14 over there that was on the right side. And then for this equation, I actually already have standard form. And so there's nothing I need to do except that, put my x in the front and my y second. So I'm just going to kind of rearrange these two terms. So I'm not moving it per se on the other side of the equal sign. So I'm just going to rearrange my terms and put my negative 8 first, and then followed by the 3y, and then followed by the negative 14. And so I just rearranged those two terms there for letter C. Now, the second step, example 2 here, the second step would be to identify what coefficients are opposites. So one will have a positive sign and one will have a negative sign, but they have to have the same number. And then what we're going to do is just circle the variable that has the opposite coefficients, because that's the whole key there to elimination. And so I want you to see here that in your first function, your y has the same coefficient and it's opposite signs, and so the key here is that when you do your elimination and you add, you'll get your x's here that you'll combine. 4x's plus 2x's is 6x's. Your y's completely eliminate, and then you have equal to here 24, and so that's kind of the start of the process of elimination. Now again, in the second one, I also noticed that my y's have the same coefficient and they are opposite signs. So again, those drop out. So here's just the beginning of the elimination. I have 2x's plus 1x would get me 3x's. My y's completely cancel out when I add my functions together. And then over here on the right side, I'll have negative 27. So that's just kind of the beginning. And then also here, for my last function, I notice that my x's have the same coefficient and they are opposite signs. And so my x's are going to eliminate. Again, just then the next step would be to actually add your two functions together. 4y plus 1y would be 5y's, and negative 8 minus 2 would be negative 10, and that's just kind of the beginning. So notice how those variables got eliminated, and then we can start solving. Check out the next video for our process.